Okay, today we're going to talk about sequences. A sequence is a set of numbers that follows a pattern. Here are three different sequences that start with the numbers 2 and 6. So 2, 6, 10, 14. You're adding 4 every time. 2, 6, 18, 54. You're multiplying by 3. Or 2, 6, 8, 14. This one's cool. This is called a Fibonacci sequence. 2 plus 6 is 8. 6 plus 8 is 14. 8 plus 14 would be 22. So each number in a sequence is called a term. And we can often use what's called inductive reasoning, which is just making conclusions based on patterns that you see to find the next terms in a sequence. So this says find the next three terms in the sequence 2, 6, 10, 14. So if I'm going from 2 to 6, what am I doing? I'm adding 4. 6 to 10, adding 4. 10 to 14, adding 4. So if I add 4 again, that's 18, 22, and 26. And this is what we call an arithmetic sequence. And that is when you are adding a fixed number, okay, every time. That's also called the common difference. So in this case, 4 would be the common difference. And the way that we're going to write the rule is you always have to start with whatever you're starting with, and then add whatever you're adding, okay, repeatedly. So on this last one, we would say start with 2 and add 4 repeatedly. It's essentially just directions on how to make your sequence. Okay, so it says find the next three terms in each sequence and write the rule. So what's happening here? We're starting with 5 and we're adding 7 repeatedly, right? So 5 plus 7 is 12, plus 7 is 19, plus 7 is 26, and then 33, 40, 47. Okay, or letter B, if you have 4 and then 9 and then 14 and then 24, we are going to say start with 4 and add, what are we adding every time? 5 repeatedly. So 24 plus 5 would be, oh, and actually there should be a 19 in here, would be 29, 34, and then 39. Okay, and then letter C, we're going to say start with 2 and add 10 repeatedly. And it would go 42, and then 52, and then 62. So the rules are kind of tedious to write, but it's just part of it. We got to do it. Okay, look at letter D. What is happening every time on letter D? We can say start with 3.2 and add 0.3 repeatedly. Okay, if you weren't sure what you're adding, just subtract them to find the difference. I'm looking for a calculator here. So on your calculator, you could just type in, I don't have mine with me, 3.5 minus 3.2, and you would get 0.3. Okay? So, oh, my dog's going cray-cray. So 4.1 plus 0.3 is 4.4, and then 4.7, and then 5.0. Rosie, do you want a treat? Come here. Come here. Come get a treat. Stop. It's on the floor. She dropped it. Okay, grab her a dog biscuit. Okay. Enough of that. On this one, okay, the rule is always start with, and then whatever we're starting with, so 6. And then what are we adding? It has to be add. We're subtracting 2, right? That's the same thing as adding -2 repeatedly. Okay, adding a negative is the same as subtracting. So then we would get -4, -6, and -8. Okay, and then on the bottom, we have 9, 8.5, 8, 7.5, 7. So you can probably recognize, okay, well, we're subtracting a half. Well, that's the same as adding -1/2. So we're gonna say start with 9 and add -0.5 repeatedly. Okay, so 6.5, 6, 5.5. Okay, let's look at the next sequence that starts with 2 and 6. So that's +4, but then am I adding 4 to go to 18? No, so we're gonna do 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. So this is an example of a geometric sequence. And in a geometric sequence, we're multiplying by the same common ratio, okay, repeatedly. So now 54 times 3 would be 162. 162 times 3 would be 486. 486, you can use a calculator, times 3, 25, 4, 8, 12 would be 1,458. Okay, so you're multiplying instead of adding. So if we turn our paper over, okay, if we have 4 and then 8 and then 16 and then 32. So I'm not adding 4 every time. So 4 times 2 makes 8. So my rule is start with 4 and multiply by 2 repeatedly. So 32 times 2 is 64. 64 times 2 is 128. And 128 times 2 would be 256. So if we look at letter H, we're going to say start with 128. And what are you doing every time? What are you multiplying by? Okay, if you're not sure, you take the second number and divide it by the first. So like 8 divided by 4 is 2. 16 divided by 8 is 2. So I know I'm taking the first number and multiplying by 2. On your calculator, you can type in 64 divided by 128, and you get a half, right? Or 0.5. Oops. So start with 128, and we're going to multiply by 1/2 or 0.5 repeatedly. So that goes 8, and then 4, and then 2. And then the last scenario that we have to talk about is when it's switching back and forth from positive to negative. Okay, so start with 10 and multiply by, okay, so 10, it's not times 2, right? And this, it's times what? -2 repeatedly. Okay, because 10 times -2 is -20, times -2 is +40, times -2 is -80. So when you're multiplying by a negative, that's what's going to make it switch back and forth from positive to negative, positive to negative. So that would be 160, -320, and 640. Okay, so on the next slides, it says identify the sequences as geometric or arithmetic, write a rule, and then find the next 3. So what's happening here? We're doing 3, and what are we? Are we adding something? What's happening? We are adding 4 repeatedly. So we're going to say, well, it's so we'll say start with 3 and add 4 repeatedly. And if we're adding, that means it's an arithmetic sequence. Okay, so 15 plus 4 is 19, plus 4 is 23, plus 4 is 27. Okay, or on the next one, we have 25, and then it goes down to 21, and then down to 17, and then down to 13. So are we multiplying by something, adding, subtracting? What do you think? We're subtracting, right? So that means we're adding a negative. So it's an arithmetic sequence, and our rule is start with 25 and add -4 repeatedly. So then you would go 9, 5, and 1. Okay, so the next few sequences, why don't you try them on your own? Okay, the next slide of 2, and then we'll come back and check our answers. Okay, on the next one, you should have said that it's arithmetic, and it starts with -8 and add 7 repeatedly. And so that's going to go 20, 27, 34. And then on this one, it's geometric, and it starts with 2 and multiply by -3 repeatedly. So, because it's going positive, negative, positive, negative. So 54 times 3 is 162. 162 times 3 would be 486, and it's negative. And I think we did this one over here. 486 times 3 is 1,458. Okay, and again, you are more than welcome to use a calculator. Okay, the next one, we have 1/2, 1/4, 1/8, 1/16. Okay, we're not adding anything the same. We're multiplying by a half, right? So look up here. If I have a half and it's going to a fourth, and I'm trying to figure out what am I multiplying by, 1 times 1 makes 1. 2 times 2 makes 4. So I'm multiplying by a half. So my rule is going to be, it's geometric. Start with 1/2 and multiply by 1/2 repeatedly. And that's our rule. And then it would go 1/32, 1/64, and 1/128. Okay, and then the next one we're going to skip. Okay, we're going to come down here to this one. Geometric, arithmetic, both or neither. This one can be both, right? Because you could say, well, you're adding 0 repeatedly, or you could say you're multiplying by 1 repeatedly. And then this down here, it's going down 21 every time. So it's arithmetic because you're subtracting or adding -21.